welcome to this lecture on numeric control manufacturing. Myself, Lovepreet Singh, Assistant Professor, School of Mechanical Engineering, Golgota University. I welcome all of you on this course, that is BTME 3009, CAM and Automation. In the today's lecture, we will discuss about the basics of numeric control manufacturing. The learning objective for the today's lecture is fundamental of numeric control technology, then advantage and disadvantage of NC manufacturing, component of NC machine tool, axis resonation, principle of part programming, type of NC systems, basics of computer assisted part programming, NC machining centers. So introduction. The programmable automation is termed as numerical control. Uh, why does it's a numeric control? Because in the automation there is use of computer, and the computer uh, can study or learn in only in numbers, that is 1 and 0. Only the Boolean operation is working on the computer. So that's why this is called a numeric control. So to control the any machine with the help of numbers is termed as numeric control. The machining steps of the parts are captured in the form of part programming. The NC machine tool are suitable when there is variation in part configurations. The manufacturing systems can be classified as discrete part and continuous part. Uh, the continuous process manufacturing system, which is already discussed in last lecture, so you can refer that. So movement of step toward NC, how we can decide whether to use the NC machine tool or computer integrated manufacturing or transfer lines. So if the part variety is high and part volume is low, then we use the NC machine tool only. If we have part variety is medium and part volume is medium, then we use the computer integrated manufacturing. And if we have high part volume and low part variety, then we use the transfer lines. So in the NC machine tool, the following functions are made automatics, like starting and stopping of machines, speed control of spindle, positioning guide of the tool tip along with desired path, feed rate control, tool change as per requirement. So these are the functions which are automatic in any NC machine tool. So let us have a look on the comparison between CNC, numeric control, CNC and DNC. First of all, NC. What is NC actually? Suppose you have two machines. This is machine number 1. This is machine number 2. Okay, we want to. These are performing the different operations, and if it's NC, that means we can make the program on its this machine itself. We have to update here only, so there is no control, although it's not connected with any computer or any other machine. So there is no connection between 1 and 2. Okay, there is no connection between 1 and 2. So the program can be edited, or it can be loaded only using this machine's interface only. So there is no another way. On the other hand, if it's CNC, that means we can the same machine 1 and 2. So in this machine we can load the program using our offline programming method, like we will make the program, write the program on a different computer, then using the punch card or USB connection, we can transfer this program from our computer suppose this is computer, from our computer to this machine. Okay, so this is the function, this is the CNC. And what is DNC? DNC. DNC, for example, this is a computer, and you have the different machines. You have the different machines, different one, machine number 2, machine number 3, and machine number 4. So all these machines, machine number 2, machine number 3, and machine number 4. So all these machines are connected with this computer, with this computer only. So whenever you want to load any program on machine number 1, we write this on this central computer, and load to machine number 1 as it's connected with this computer. And if we want to change something and upload to machine number 2, we can upload here only. So this is the DNC. So DNC requires a large memory system for storing and data. The program structure, basic structure of NC machine tools. The basic structure is shown in the diagram. The main part of the machine is machine control unit. Machine control unit. It's here. This is the basic part which is connected with the computer. Next is machine tool. This is the part. These are the parts of machine tool which is connected here. Drive unit. This is drive unit. This is the servo controller. Servo controller is here in the machine control unit itself. And feedback device. Feedback device like sensor, transducers are there. Encoders. These are the feedback devices which are connected with this machine tool. So NC manufacturing process. There are 4 steps in the typical NC manufacturing process. First is to model the parts to be machined in the CAD environment. Obtain the machine control commands such as cutter, contact, and location data to the CAM system. Convert the cutter location data into G codes. Load the G codes into NC systems and implement the NC machining of the part. So like we have to make the engineering drawing, then process planning, then part programming, then tape preparation, then NC machine tool, then it's the final product. So this is the procedure step for NC manufacturing. So process planning, a process of listing a manufacturing instruction for various machine to produce a finished part. There are 3 approaches to accomplish the process planning task. First is the manual approach, second is the computer assisted variant approach, then computer generative approach. There are 2 levels of business process planning systems. One is high level planning and next is the low level planning. The principal axis to plan the sequence of positioning and movement of tool relevant to workpiece, it's necessary to establish the standard axis system. Suppose according to our traditional system, this is Y, this is X, and this is Z. But on the machine, this is Z, this is X, this is Z here, and this is Y. Okay, so this is the coordinate system for machine. Specification of origin of coordinate system. So as a programmer, you have to specify what is the origin for starting of your process. So a part program can use 2 methods for identifying the origin of the system. These are fixed zeros methods and floating zero methods. In the fixed zero, the 0 point is always situated at fixed location on the machine table. So that means if the machine table, if it's a machine table, and then the fixed zero method, the 0 is always fixed. In the floating zero methods, the part programmer decides the location of 0 point, always according to their convenience. The modes of numeric control programming. The NC programming, the dimensions of an object can be described in two modes. First is absolute mode, second is incremental mode. In the absolute mode, we start from the like a fixed position. This is 0 0, and we measure the all the dimensions from this 0 0 only. In the incremental system, this is a 0 0, but if we are here and want to shift here, then we for us this is the 0 0 in the incremental positioning system. So motion control system in numerical control machine tool. First is point to point, means we start from here and we move here this point, and then we want to move here, then there is angle, so it's a point to point. And second is straight cut system, where we give the definition of straight cut. This move like this, then here, then here, then here, then here. Contouring, where some curves or some arc are there, then the contouring motion is used, where the tool move according to their curve. Feedback device and servo control systems. The feedback devices are termed sensors or transducers. There are two types of transducers. The main function of sensor and transducer is the sensor its function is to, suppose this is the input, this is machine control unit, this is comparator, and this is amplifier, servo motor, machine tool, and the main command is processed through machine control unit, then it's sent to comparator, then there is amplifier which amplifies the signal, and then there is servo motor which accept this command and moves according to which moves the machine tool according to our command. Okay, so our command is here, and machine tool moves according to this. But suppose if we want to move from here to here, and servo command has given the tool to move from this point to this point, but it's moved up to here, so in that case there will be a sensor which sense the difference between this and this region point, okay, and calibrate with our command whether it's as our command is fully executed or not. And according to that, there is transducer which is connected, which is the second part of your sensors, which send the signal that there is a difference between target position and our current positions. So how much is difference? This is our difference. So this difference D is sent to the comparator again. Then there is amplifier which transmits this signal to again servo motor to move to this much D as distance. So this is the closed loop NC system. If there is no feedback, then this is open loop closed system. Application of numeric control. The numeric control is most appropriate under the following conditions: when machining component with high accuracy required, when machining component undergo frequent design changes, when it's involve repetitive production of precise parts in a small and medium lot size, if it involves several operations on components, when a part has complex geometries. The advantage of NC are as follows: there is increased productivity due to reduced step up and lead time. There is reduced scrap due to elimination of human errors and high accuracy of NC systems. There is an increased rate of production due to heavy reduction in non-machining times. There is higher accuracy leading to interchangeable use of component. Better quality control is possible. The disadvantage of NC are as follows. The NC system requires high initial capital cost. It needs high investment for maintaining and breakdown. For part programming, skilled labor is required and involves cost of pre-programming. So next is numeric type of numerical control: simple manual NC systems, computer numerical control, and direct numeric control. This is already discussed in last previous slide. So machining center, a machining center is an NC machine tool which can perform several different operations in a single settings and can automatically change the tools while being under programmable control. So this is the vertical milling center supplied by MTAP. Next is the features of machining center. Like conventional machining tools, a machining center has a following component. That one is bed, saddle, column, tool changer, spindle, servo system, machining control units. So along which axis the movement is there, like saddle, it's move the linear motion, it's give the linear movement, and axis is x-axis. Like column, it's a linear motion in y-axis. Table, linear motion in z-axis. Spindle, contouring and tilting a and y-axis. Rotary in b-axis, rotary table. So turning centers, there are two common types of turning center in use. One is CNC turning centers and CNC turning. So this is a turning center schematics supplied by MTAP Corporation. NC programming. The NC machines operate according to received code instructions, that is input data. Generally, the word tape format is used to indicate the arrangement and order of coding instruction over a punch tape. The commonly used words and the order of their use in blocks are briefly given. And words, it denotes the sequence of number to identify the block. The complete word usually consists of the 3 digit with a n as a prefix. The G words, this is called preparatory word, used to prepare the control unit for operating instructions. Next is the CNC program structure. There are four basic terms used in CNC programming. First is the character, then word, then block, then program. So first we write the characters. With combining these characters, the word will be formed, and combining these words, the block will be formed. Then the program will be completed. Character is the smallest unit of a CNC program. It may have a digit, letter, symbols. Words is a combination of alphanumeric characters. It can contain a single instruction to a machine. Each word begin with capital letter followed by numerals. These are used to represent access position, feed rate, speed, preparatory command, and miscellaneous function. A program block may contain a multiple words sequenced in logical order of processing. So the program comprises of multiple lines of instruction blocks which are executed by machine control unit. Here is a simple CNC program structure which is normally used. So the percentage in this case is symbol. So 000, that is program number and program ID. This is a sample program structure for demonstration, that is program description. So number 10, this is N10. This shows a step length because we cannot determine which in which step length what is the issue. So here the step length is given, that is N10, N20, N30, and 35. Likewise, you can give any step length. So N10 is a step length, Z21 is a unit setting command. Then in the next step, N20, Z40, G80, G49, these are the initial commands. Next is the T1, that is tool 01 in waiting position. M06, this is for replace present tool, add a spindle by T1. So this is the simple command program for the CNC. Here is the image for G codes for milling and turning operation. As you can see, this is Z double zero. This is rapid linear position. So Z01 linear feed interpolation. Likewise, you can remember this codes for which will helpful in writing a program. These are the M codes for milling operation. M code are miscellaneous codes, and we can say for understanding purpose these are the machine codes which control the machine properly. So the M01 program stop, M01 optional stop, M02 end of program, M03 spindle on clockwise, M04 counterclockwise, M05 spindle stop. Likewise, these are the machines code or miscellaneous code. Next, this is the G codes for turning operation. G codes mean preparatory codes, or sometimes we refer this as a geometry codes, which control the geometry also. So these are the different codes up to likewise Z90 is incremental programming, Z90 is absolute programming, Z91 is incremental programming. Likewise Z90 cutting cycle A, Z71 finishing cycle A. So likewise these are the G codes for turning. So here is an exercise for CNC part programming. So here the write an efficient CNC part program to drill 35 hole of diameter 0.5 inch in a machine component as shown in diagram. And so here all the dimensions are given. The raw material to be employed in a mild steel of 0.4 inch thickness. Explain the important function used for CNC board. So here I have written a one sample program for this. So this is block 1 percent. This is the program number. So this is the step length, and this is the codes which is used for this sample program. So in continues to last slide, this is a block 1 that is indicates the start of program. Here is the start of program. Then block 2 it specify the program ID, and it shows usually alphanumeric codes. Block 3 it says that the entry for dimensional unit imperial form. Next is that is inches. Next is Z block 4 Z71 Z70. It select the plane of operation as XY plane. G40 G80 G49 are used to cancel all usually cycles that might be left in on mode during last execution of last code. Z90 select the method of specify the feature between absolute. So we are going to use this by the absolute program. Next is the block 5. It sets the program 0 on the work part, and there are major environment programming that require established mathematical relation, machine tool, and control. For the system, we have to control the part, that is workpiece, plus drawing, plus material. For the tool, we have to control the holder, plus cutting tool. So these are the further command for the from here also. So these are the block 5. The machine 0 point. It is also called a home position or machine reference point. It is the origin of machine coordinate system. On all the CNC machines, machine 0 is located at positive end of each axis travel range. So here this is the machine 0. Here this is machine reference point. From the top view we can see this is the machine 0 xy. Okay, on the front view this is the machine 0 xy. This is z motion, this is machine table, this is gauge line, and this is in the top view this is y motion. Okay, so the programmer should know what is the machine reference point and what is the machine 0. So these are the reference which you can refer for further studies, and thank you.